Good afternoon, dear participants of the conference. Allow the authors to present the result of a study on economic mathematical model for complex risk assessment of the enterprise investment project using fuzzy logic. Quite often to assess the risk of enterprise project, the information is non-numerical. It is necessary to return both quantitative and qualitative information in one system and the formation of a single quantitative comprehensive indicator. In order to form a comprehensive risk assessment of the project, it is advisable to use fuzzy logic and obtain through a comprehensive numerical risk assessment of the project. The structure of the presentation includes the following blocks. And project management knowledge areas according to the PMBOK standard, and advantages of the model proposed by the authors, which is based on the approach of Alexei Nedosekin, and identification of risks that affect the project, and stages of the proposed model. And also slide 5.4.11 shows the stages of the implementation of the proposed model. And the issue of project management is quite relevant. This is especially true of Ukrainian enterprises. The use of the project management by Ukrainian companies in various industries is growing rapidly. This is due to obtain the maximum results due to the implementation of projects using available resources. And according to the PMBOK standards, there are the following areas of project management knowledge: and project integration management, project scope management, project time management, project cost management, project quality management, and project human resources management, project communications management, project risk management, project procurement management, and project stakeholder management. Project risk management is one of the key areas of knowledge because already at the project planning stage allows you to determine whether it is appropriate to implement the project, which risks are critical, and how to coordinate the major actions to successfully implement the project. And there are different methods of project risk assessment: expert, statistical, analytical, rating, etc. Simulation using game theory, utility theory, fuzzy logic is also used. The main advantages of the proposed model using the approach of Nedosekin are: allows you to manage the risk of the project to maximize the likelihood of its successful implementation, and compare alternative project and choose less risky, and minimize the level of unforeseen project costs. And also the presented approach allows to determine a comprehensive assessment of the risk of the investment project of the enterprise, which indicates its universality and creates conditions for its extendability for different enterprises. And before forming a comprehensive risk assessment, it is necessary to determine the risk that may affect the successful implementation of the project. Of course, for each individual project, these risks are individual. So you should be quite careful to form a system of project risk, taking into account the specifics of the enterprise, the specifics of the project, and timing of its implementation, financial aspects, etc. The task of determination a comprehensive risk assessment of the project within this study is implemented by a construction company, which assessed the risk of a new investment project for the construction of a residential complex. The experts identified the following types of risks and their components, which are typical for a residential construction project and have an impact of the results of the project, and selected for the formation of a comprehensive assessment, such as technical, external, and organizational. And the proposed project risk model consists of the following stage: formation of initial data using expert opinions, and construction of a hierarchical tree of project risks, determination of weight factors, Fishburne weights, of project risks, selection and description of membership function and linguistic variables, conversion of input data provided by experts from scope scale into linguistic terms, and recognition of qualitative input data on a linguistic scale, determination of a complex risk indicator of the investment project, and interpretation of a complex indicator. And we can see stage 1, formation of initial data with the use of expert opinions. Expert estimates the probability of occurrence of risk using a score scale from 0 to 100 points. For each indicator, points are added and the average is determined. Next, the concordance coefficient is determined, and the table shows the information provided by experts regarding the assessment of the probability of occurrence of each of the selected risks of the project on a scale from 0 to 100 points ascending, and the concordance ratio according to is 0.7, which indicates that the opinions of experts are consistent. And the stage 2 and the construction of hierarchical risk 3 of the project using the system of advantage relations. It's possible to note the ratio of balance between the group of technical and external risks and the ratio of their advantage over the group of organization risks according to the experts. Equilibrium and risk preference within each group are similarly reflected, and the obtained system of preference ratios can be used to determine the risk weights of Fishburne weights. And stage 3, determination of weights, Fishburne weights, according to the system of relations of advantage of the previous slide, the system of Fishburne scales table is formed. And after convolving the weights of different levels of the hierarchy, the following generalized weights level of influence were obtained. And we can see that R 1.1 equal 0.2 and 2.1 equal 0.133 and 3, and etc. We can see in this slide. And okay, stage 4, selection and description of membership function and linguistic variables. The linguistic variable risk level with the term set of A values was formed. The triangular membership function, and with the following linguistic terms was chosen as membership function: low, medium, medium, high, and distributed on the scale from 0 to 100 points. And we can see membership function on linguistic terms, and 0 doesn't belong, and 1 belongs to all 100%, and the parameters A and C characterize the base of the triangle, and the parameter B is vertex. Okay, and the step 5, transformation of the initial data provided by experts on the probability of occurrence of each of the risk from a score scale to linguistic terms, and the obtained average scores of the probability of occurrence of each of the risk, and translated into linguistic terms according to the selected membership function. According to the table, it can be seen that among the risks are risky both with a low probability of occurrence and with a very high probability. The indication of two linguistic terms for risk indicates that the obtained average scores of experts are on the body of two terms. And stage 6, recognition of qualitative input data on a linguistic scale. So the probability of risk are 1.1 in accordance with expert opinions, and linguistic terms refers to the level of medium 96% and high medium 4%, and the risk are 1.2 medium 30% and high medium 70%, and etc. We can see in this table. And the next is stage 7 and 8, definition and interpretation of the obtained complex indicator. And according to the selected membership functions, the nodal points in which the membership function is 1 are equal to 0, 25, 50, 75, and 100. And the complex risk indicator of the investment project is 51.8 and points, and the value of the complex risk indicator is medium 93%, and the high medium 7%. And the most critical for the project risk are 1.2, R2.2, and R2.1, and R3.1, and to transfer them to an admissible green zone, and implementation of additional measures for ensure the quality of raw materials, application of sanctions of suppliers up to deputy other equipment, and staff training during construction, search the implementation of reserves to reduce production costs, transit to alternative source, reduction of the share of improved materials and spare parts due to the maximum use of domestic and primary local, etc. And therefore, the proposed model is universal, and can be used after its adaptation to determine a comprehensive risk assessment of any project of the enterprise, and further research will be related to the implementation of the developed model in the knowledge management system of the project-oriented enterprise. And thank you for your attention.